So tonight we're going to go on a journey through space and time, all the way from the land of Canaan to the South Pole to Chile and beyond. I will give an overview of what the Torah says about cosmology, if we can endeavor to ask such a question, and how the Torah relates to science in general. I'll have a little explication of something that really resonates with me, passages in the Torah that I find particularly brilliant and full of wisdom. And then I'll conclude with some homework. I'll actually start with some homework too. So let me share my screen, and there'll be questions at the end, and you're welcome to ask them in the chat room, as well as holding them to the end. I'll do the Q&A itself. And I want to welcome my friends on the East Coast. I see a bunch of you out there on the East Coast. Thank you for staying up late. Hopefully it'll be worth it. But as you know, we astronomers, we do it in the dark. We're used to staying up all night and then sleeping during the day. So hopefully you'll get a little taste of what life is like for a professional astronomer. So I call this If You Can Count the Stars, and the reason why that'll become apparent, hopefully, in just a little bit, and that'll be kind of the theme. And it will relate to this project that I've been involved with for the last couple of years, which I call Into the Impossible, which is to try to test, as Sir Arthur C. Clarke, the namesake of the center at UCSD that I am associate director of, we aim to push the boundaries of the possible by seeing the limits of going into the impossible. And we're going to see that that is a mission as old as our people, as our history. And hopefully that'll become clear as we go on. So let me know if you cannot see my slides. The first slide is actually just an outline, just like you're used to from your college days. If you're one of my older students joining in tonight from around the world, or if you're a young student, you'll know the rubric. We're going to talk very quickly about cosmology from two different perspectives: the perspectives of an astrophysicist and the perspective of a Torah, observant Torah, so a different kind of observer, and what they reveal, what they have in common, where they differ, and how do you reconcile when one seems to be in conflict with another. I think that's very, very crucial for modern people to confront. Because as it is said, the signature of God is truth. So if something isn't true, then it can't really be found to be resonant with these notions of eternal truth and perhaps ultimate truth. I'm going to talk a little bit about my Jewish journey, which will take us around the planet and maybe beyond. And then I'm going to have some interesting confluences between the study of what we do in cosmology and also something that the Torah speaks about at great length, which is the most humble substance in the world, dust. And how hopefully we'll see a delightful connection between those. And then a simple question, if we have time, I'll ask if science can prove God. That's the question I get second most. The first most question is, how can you be a scientist and believe in God, in the Torah? And then the second most frequent question I get is, can science prove God's existence? So let's start with some homework. So if you're watching this, you can do some homework, even though I don't allow my students in my class to take out their phones during a lecture. If you're watching it on a computer, you can take out your phone, point the camera at that strange alien typography, that little QR code. It'll take you to join my mailing list, which will keep you apprised of things all around the universe. We have 5,000 people around the planet that are members, and I send out interesting, fun factoids, tidbits, useful tools, tricks, and brain teasers throughout the month. Only once or twice a month do I send something out, so I won't clog up your spam box. And that wouldn't be right for me to do. And I'll keep you apprised of giveaways and fun things I do to keep people really engaged, because I believe my mission as a publicly funded scientist, and all scientists are publicly funded, there's no such thing as someone who wasn't supported by the government and therefore by the taxpayers. I believe we have a moral obligation, that's right, a moral obligation to give back, to teach, to share what we learned based on your tax dollars. So if you are a taxpayer, and I assume all of us are, we should pay back the debt that we owe to you as scientists. So I do that through my email list, and the other way I do it is through my weekly videos that I post with conversations ranging from Nobel Prize winners to astronauts on the space station traveling at 17,000 miles per hour. I've had the honor to interview both, and it's really a lot of fun. And I do kind of explainer videos, and my mission is to maintain curiosity, because curiosity is more important in my mind than passion. Passion kind of comes and goes. Don't follow your passion, follow your curiosity. It will always be there for you. So you can click your camera, go to that weird code on the upper right, and it should take you to sign up for my channel. You can subscribe to my channel. I see many of you are doing this homework in real time. I love it. So that is wonderful. And or you could just go to YouTube and type in my name. Okay, that's the homework. So now we come to the beginning. And in the beginning of this webinar, there was a book. That book is called Genesis. And today we're going to be talking about the description that you see in front of you. This is from, I believe, the King James Version, perhaps. Some people call it the Bible. Some people call it the Torah. Some people call it the Old Testament. I don't care what you call it. But we're going to talk about the statements that are made here, where it says, in the beginning, God created the heaven and the earth. And then it goes into much more description over the course of the remaining 6 days of the week, the first week of creation, which in some characterizations, in the Bishop Usher, so forth, characterize this as occurring in the year 4000 approximately, in what we would now call BCE, before the Common Era, before Christ, if it's using BC. And so we're now 6,000 years approximately later, and the question is, how do you reconcile this kind of description, this kind of depiction of a finite and really not that long period of time compared to the scientific explanation, which we all learned about when we study the Big Bang Theory? So we're all experts in the Big Bang Theory, most popular television show of all time, according to some. And it features a character named Sheldon, by the way. He's based on a real guy who I had the honor of interviewing, Sheldon Glashow, winner of the 1979 Nobel Prize. Shared it with somebody I'm going to talk about, Steven Weinberg, renowned, another famous Jewish atheist. I didn't have Steven Weinberg on my podcast. Unfortunately, he's now passed away. But Sheldon is based on this real, really incredible intellect named Sheldon Glashow. And so these Nobel Prize winners carry great resonance throughout our culture. And of course, there's no more funny and relevant show than this one for most cosmologists. So I want to take us on a depiction of 3 verses, which we'll come back to frequently throughout this discussion. And it involves, these 3 quotes involve the following 3 substances: dust, sand, and stars. And the title of the talk, or subtitle of the talk, no, it was the title of the talk, said, quoting from Genesis chapter 15, it said, God took Abraham, him as Abraham, or Abram, he was known as Abram, and he said, look up into the sky and count the stars. Count them, if you can. That's how many descendants you will have. And this was talking to, I believe, a 90-year-old person. Rabbi Artel will hit me later on if I'm wrong. But about approximately 90 years old was Abram at this time. He had no kids, and let alone did he have this huge number of kids. And there was no prospect of this with his wife Sarah, who was, I believe, 80-something at the time, of them ever having kids, let alone such numerous profligate expansion of their own personal universes. So we'll come back to that particular quote. There's another quote that involves dust, and we'll talk about that one as well. I will make your offspring like the dust of the earth, so that if one could count the dust of the earth, then your offspring could be counted. And then lastly, it says, I shall surely bless you and I will multiply you like the stars in the sky. All right, you already said that. Hashem, you're being kind of repetitive here. But then it says, like the sand on the seashore. So we have 3 different metaphors, comparisons, that God is saying and promising to Abram, who will later become Abraham, the father of all the monotheistic religions, Judaism, Christianity, and Islam. And here he is saying these 3 different comparisons. What do they have to do with each other? Why use such metaphors? And what do they have to do with modern cosmology? So let's turn to the biblical description of Genesis first. So it's interesting to note there are 6 days of creation depicted where God makes different things. And most of the time he's making stuff, he's not making something in a void, he's making something and a comparison, something and its opposite, something and something to complement it. For example, he makes Adam, but he also makes Eve from Adam. And that involves dust, as you know, as well. We'll get to that later on. He makes water, he makes light, and there's difference between darkness and light. So there's all these comparisons, day and night. So everything is done in comparison to something else. So this is a nice woodcut or depiction colorized by Photoshop in 1493. And it depicts the 6 days of creation in some fashion, sort of from an outside observer. Maybe it's God's perspective. God starts off with creating the waters, the upper waters, the lower waters. We'll go through that in just a second, what was actually created. But note that it's counting from the top, so it goes 1, 2, 3, 4, and the 4th day is on the lower left, and that becomes yellow in the background, and that's because the 4th day is the day in which the sun is created. So wait, you may think, well, that's kind of weird. How do you have a day, which we define as a 24-hour period? How do you define a day or an hour when the sun hasn't been created until the 4th day? What is that meant to teach us? It must be telling us something. Obviously, people knew that day was caused by sun, night was caused by the absence of sun, that there were other luminaries in the sky, the moon, the stars. They knew that, even if you want to say they didn't know cosmology, they didn't have the benefit of the Hubble Space Telescope. They still knew that day followed night because of the repetition of the daily cyclical pattern of the sun rising from our perspective and setting each day. So how could you have a day without the sun? It must be coming to tell us something very interesting. And I'll skip to the punchline. In that context, for me, not as a cosmologist, but as just a person who is comfortable with basic logic, that it came to teach us something that even the sun and moon, which were throughout history have been worshipped as deities, that they were created. So it was unambiguous that the earth and the sun and the moon were not gods. Say what you will, if you believe it or not, if it was literal or not, nevertheless, you have to agree that the time, that the perspective that's being depicted is obviously one that's showing a creation of things previously considered to be gods. The sun and the moon and the stars. So this was rampant throughout the Middle East and throughout history, that those were worshipped. And then later on, things like trees and herbs and so forth were created. But even it says that you weren't able to see the light from the sun until that very special 5th day in the middle lower panel. And then later, the culmination of all of creation, according to the biblical sources, was the creation of man, or humans. Man and woman were created, as it says. So what I think is so interesting is that people come up to me and they say, oh, Professor Keating, how can you believe in this? It's like the Torah and Judaism and so forth are incompatible with science. And I say to them, imagine you picked up a book. And in that book, it was a 1,000-page book. And in that book, there were 999 pages. And they were dedicated to the history and the background behind the National Basketball Association. Okay? So there's a book, and 99.9% of it is about the NBA. And then there's one page, and it's about the American Revolutionary War. And then you say, okay, well, that's kind of weird. I don't know what they really have to do with each other. Maybe NBA started in America, it was American, who knows, but okay, so it's in there, maybe it's relevant in some way. Then you turn the cover over and you look at the cover and it says, the history of the American Revolution. You'd say, this is very weird. Like, this book it has a little bit of that in it, but most 99.9% of it is not about that. Well, guess what? That's the exact ratio of verses that cover these 6 days. There's 35 verses in the Torah, in Genesis, about these events. And there's 35,000 total verses in the 5 books of Moses, the Old Testament, the Bible, whatever you want to call it. So it's the same. It's the same 0.1%. So to me, again, just from basic logic, you have to agree that the Torah is not coming to teach us about science. And in fact, Torah translates to wisdom and teaching. But the word science comes from Latin scientia, and that means knowledge. And there's a very big difference between knowledge and wisdom. As the saying goes, knowledge is knowing a tomato is a fruit, but wisdom is knowing not to put it in a fruit salad. And I think when we look at this chronology, it's not meant to teach us about genetics, evolution, cosmology, and so forth. So many of you may be feeling like maybe you should tune out now. I hope you won't. But the point is, we have a depiction that's coming to teach us something perhaps about wisdom, not necessarily about the knowledge of the physical universe. And nor should we go there to glean information about physics. If I am teaching cosmology this quarter, and if one of my students, tells me that they're, they don't believe that the universe is expanding because it's not in the Torah, I'd say, well, you're free. It's a free country, but that's not accurate to describe it as part of modern cosmology. In fact, we're going to go through some of the competing cosmologies that the Torah supplanted, uniquely so, for thousands of years. Again, I'm not going to use that as proof that the Torah is correct, that God definitely exists, or that science somehow backs up the Torah description, as some people have claimed it does. I don't believe that's possible, because I don't believe that's the mission of the Torah. And yet, I believe the Torah is the most important book ever read. I've written 3 books. Well, I've written 2 books, and I've recorded a 3rd book, an audio-only book. And when they all start off, they're kind of, it's nice to see a book, it goes to, high ranking on Amazon, and you can get your author ranking on Amazon. And then within a couple of days, it falls off and it goes down to almost 0. I mean, it goes down to like 1 million or something like that out of the 10 million books on Amazon. So you feel a little dejected, but it's natural. That's what happens. Except if your name is, Hashem or God, and you wrote a book called the Bible, and that just kind of like stays at number 1 for all time. And so what did the Torah have to do? It had to do something that neither one of my written books or nor my audiobook can do, which is to speak to people thousands of years ago and continue to speak to people for thousands of years to come. That's something that only wisdom can do. I hope that my books are superseded and rendered obsolete by discoveries that I make or my colleagues or my students make. I hope the works of Stephen Hawking are completely obsolete. And any good scientist should say that. They hope that their work is superseded, because that's the way that science makes progress. And we'll explain why in just a bit. So there's a depiction. I'm not going to talk too much about it, how it's depicted. It's certainly not how we understand how the universe, how the earth is shaped or so forth. Again, we have to go deeper and talk about, well, what is it trying to teach us? What is it trying to do? Is it trying to really understand the scientific method that wouldn't be invented until the middle 1600s by Galileo? Or is it doing something different? And if so, what? And where does it establish its expertise? Obviously, modern cosmologists like myself and others have expertise in our domain. The question is, when you get into trouble, is when you try to shoehorn or force one into the other domain. And I can hear arguments on both sides that say the Torah should contain all this wisdom and truth, and some that would say it has nothing to teach us. So it's a careful line to walk, but I think that's the most fun, challenging, and interesting way to approach this immense book of wisdom that we call the Old Testament or the Bible. So how does that depiction of the first 6 days, how does it relate, or what is it to be compared to? It really is compared to a theory that we call the Big Bang Theory, which posits that the universe came into existence ex nihilo, from nothing, which actually sounds very similar to the Bible's description. The Bible doesn't talk about anything before the Genesis 1:1. It talks about the beginning, establishing a singular event before which there were no days or times, perhaps, and after which there was history that could be recorded and characterized both in the physical world to a minor extent, 0.1% extent, and later to understand the evolution of specific peoples in the Near East and Middle East. Now, the Big Bang Theory was brought about through a series of scientific observations, hypotheses, and the application of the scientific method. And yet, it wasn't really verified for many decades. And in fact, it was never proven. And it still isn't proven. And before you start to object, if you're coming to this as a scientist and saying, like, even this cosmologist doesn't believe in the Big Bang, well, that's the whole thing. When you believe in something, it means you don't have evidence for it. It means that you are necessarily, if you have faith in something rather, it means you don't have proof of it or data or evidence. And in science, we can't really prove things. We can't do a good job of proving something that took place once in the history of the entire universe, namely the birth of the universe itself, unless that's not what happened. And I'll explain what I mean in just a bit. So if you look on the right side of this plot here, you see these galaxies and whatnot. And the galaxies that you see will later look like the Milky Way galaxy and will harbor planets, and those planets will have people upon it in the modern cosmological interpretation. We know of hundreds of billions of galaxies. We know of billions of stars that are in each galaxy. And we know that inside around each star, there are perhaps tens or thousands of planets and asteroids and comets, just like our solar system harbors. And in fact, there's so many stars that are just like the sun, that have planets just like the Earth within them, that we've almost stopped counting them, and now we're trying to learn more and more about their properties in the hope, some say vain hope, I'm not going to talk about that now, although I've expressed it on other people's podcasts, that they will find life and perhaps even intelligent life on other planets, around other stars in our galaxy and perhaps in other galaxies in the universe. So again, what is Abraham commanded to do? It says, go out and count the stars. Again, Rabbi Ertel, correct me. It's in a command form. It's saying, go and count the stars. And then it says, if you can. And if you can do that, then that is what your offspring will be numbered. So here's an image of a host of pixels of light. And every single smudge from this picture, taken by the Hubble Space Telescope about 25 years ago, every single smudge of light, every speck of light, with one exception, is a galaxy. So there's only one star in this whole picture. That star is in the just below the word the, and it has this kind of cross-like pattern, double cross pattern. That's the only star. That star's in the Milky Way galaxy. And every other speck of light is a galaxy outside of the Milky Way galaxy, potentially just like the Milky Way galaxy, harboring perhaps 100 billion or a trillion stars in each galaxy. So how could you count the stars? Well, we'll come back to that in just a bit. So I said, scientists don't go about talking about things they have faith in or they believe in. And the Hebrew term is emunah, from which we get the word in English, amen, meaning truth. But that's a statement of faith. I don't have faith that gravity is going to cause this object to fall. I have evidence for that. And we have a superseding theory that explains, based on observational data, through the rigorous process of refinement that we call the scientific method, that behavior will be replicated. But it is possible in some circumstances for something that has been observed in the past to no longer behave that way in the future. That effectively there are forces in the universe that behave like anti-gravity. And in fact, one of them was established by Albert Einstein himself about 100 years ago, a type of anti-gravitation, a type of anti-repulsive gravitation, which was totally in contradistinction to anything ever conceived of before. And the reason he conjectured that was to adhere to his worldview of how the cosmos must behave, that he believed we lived not in a universe with a singular Big Bang origin, but in a static universe. And we're going to talk about that. But the statement of what scientists do or do not do, we don't really prove things. We typically will prove things wrong. We won't prove things right. I can't necessarily prove to you that there is right now a purple unicorn on the North Pole of Neptune. We cannot physically do that. You could disprove it if you could go there and so forth and see it, but you can't prove and have any physical evidence instantaneously that that's there right now. So you can't prove, or you can't prove something happened if it only happened once in the course of history. So what this philosopher Karl Popper said is that you shouldn't look to prove things, you should look to disprove everything else. And what will be left is the closest approximation to the truth. For example, many of us know for certain the Earth is not flat. But very few of us know that the Earth is not a perfect sphere either. So both of those statements are wrong. If I say the Earth is flat, I'm wrong. But I'm somehow more wrong than when I say the Earth is a perfect sphere, even though I'm wrong when I say the Earth is a perfect sphere. It's not. Because of the rotation of the Earth, it bulges at the equators and becomes a little bit like pear-shaped and squashed as it rotates. So it's not a perfect sphere either, and yet it's more close to the approximation. That's what scientists should be doing. Should look for experiments that come closer and closer to truth, to the accurate description, and then parameterize what we do not know. So what are some of the alternatives to the singular origin of the universe? Turns out there's a lot of them. I'm not going to read them all here, but one of the most important ones is called a cyclic model. And this is artwork from about 1000 BC, talking about the universe as cycling through time from an Egyptian Book of the Dead. And this, again, the Jews had no lack of familiarity with Egyptian texts and Egyptian knowledge. The Torah is a tree of life. Their book was a book of death. Their God was the sun god to the Jews. The Jews said that Hashem, that God, created the sun. So how could it be a god? There's a lot of counterpose, a lot of counterpoint between Egyptian culture and the Hebraic culture. But nowadays, we still have colleagues and friends and working on my project called the Simons Observatory that are working on a type of cyclic cosmology where the universe cycles through endless periods of expansion and contraction over uncountable eons of time. And this occurs with the same dynamics that we would observe, and this stands in contradistinction to a single universe. A universe that's infinite in time is not created at a point at which an author, be it God, Moses, whoever, could say was the beginning. It loses meaning if it's a periodic cyclic universe. Therefore, if you could prove this model is wrong, you would come some way to establishing some more credulity in the Big Bang Torah description, if you will, of a single event that had a single beginning. There were no shortage of other cosmologies that weren't dynamic like that previous one. There was one by Aristotle. The universe was static, fixed in size, unchanging for all time. Newton came along 2,000 years later with a steady state static universe in which he had to posit an unstable universe that was somehow magically kept at bay from gravitational instability and collapse. This mode was then built upon by Albert Einstein, worked on Isaac Newton's laws, improved them, came up with a new theory of gravity that incorporated an anti-gravitational force to keep the universe opposed to the contraction that would surely result from the Newtonian description. Turned out he was wrong about the philosophical underpinning of this term, which he called the cosmological constant. But later, about 80 years later, we did measure that the universe not only has a cosmological constant, but it's causing the universe to get bigger in its size and its rate of expansion with every passing second for all time. And that's called cosmic acceleration. Now, some of these models were appealing, especially to atheists, like the late, great Steven Weinberg, who, as I mentioned, passed away. Shared the Nobel Prize with old Sheldon Cooper, the character in which he's based on, Sheldon Glashow. He said, the steady state theory is philosophically the most attractive theory because it least resembles the account given in Genesis. In other words, this atheist happens to be born Jewish, but atheist scientist is saying that what makes the steady state model, which is an antithetical concept to the Big Bang Theory, it posits the universe has been around forever. He's saying that's attractive because it doesn't involve anything to do that could be correlated with religion, as does the Big Bang model. So it's pretty amazing. And so even though Hubble had evidence that the universe was expanding and was dynamic, it really took until the 1960s until there were theoretical predictions as well as experimental observations, including the subject that I study called the cosmic microwave background, or CMB, that supported the fact that the universe began or was at one point incredibly hot and dense sufficiently so to cause nuclear reactions to fuse lighter elements into heavier elements, producing the periodic table left upper hand entries. And that was a decisive blow against the steady state model. It doesn't prove the Big Bang, but again, that's not what scientists do. We're not in the job of trying to prove something happened. We're trying to essentially disprove any other alternative. And then the preponderance of evidence, Occam's razor, if you will suggest that the most likely result lies outside of those disproven alternatives and will be corroborated by evidence, sometimes circumstantial, of things like the Big Bang. Now, many people throughout history have picked up on the corollary between the Genesis 1:1 description and the observations both of Hubble and of the cosmic microwave background in the 1960s. In particular, one who was an agnostic, Robert Jastrow, he wrote in a book called God and the Astronomers, he wrote, "The scientist who's lived by faith," meaning that, like the Weinberg-type scientist who had been hoping that the Big Bang was wrong because it was too theistic in its application, he said, "That story ends like a bad dream. He scaled the mountains of ignorance. He's about to conquer the highest peak, pulls himself over the final rock. He's greeted by a band of theologians who have been sitting there for centuries." Meaning that the evidence for the cosmic microwave background, just like Hubble's evidence, seemed to be suggestive of and was used by theistic proponents. Namely, the Pope Pius in the 1930s and 40s took upon the work of Hubble to say that this proved there was an origin of the universe, just like in Genesis. And this guy Jastrow saying a similar thing 30 to 40 years later, based on completely different evidence. And that's what you want as a scientist. You want multiple types of evidence pointing to a singular explanation that all agree and build consensus. That's what we in scientists do. We can't say 100% that anything, that evolution is occurring, that global warming is occurring, but you can have a preponderance of evidence for multiple disparate fields that will allow scientists to build powerful consensus, though admitting we can never prove unequivocally something is true or correct or definitive. So again, modern cosmology history starts with the Big Bang on the left, and then produces a cosmic microwave background. That's what I study. And what I did, along with some colleagues, is create an experiment that effectively was trying to refute, if you will, alternatives to the Big Bang hypothesis, which would be, if we were to be successful with this experiment called BICEP 2, we would measure the aftershocks of the Big Bang. It's as close as you could get to taking an infant baby picture of the newborn embryonic universe. So I've said most of this, the Torah description versus the scientific description. People like Karen mentioned this, Gerald Schroeder. I happen to have violent disagreements with him about a lot of stuff. And nevertheless, there are people that try to shoehorn in to the 6 days of creation a literal phenomena of passage of time corresponding to each situational event that's taken place, only a tiny bit of which is actually indicated on the plots on the left. So the plots on the left is showing time after the Big Bang in seconds and then years, and then leading up to the 1990s when some of us were born or alive. And it's trying to then shoehorn in the elapsed time according to the cosmology of these different events. I'm not going to get into that. I've spoken about that elsewhere, but this is a very, very fraught process to try to do, because as some of these processes depend very sensitively on the conditions of preceding epochs, and it's essentially impossible to make definitive predictions as the universe becomes more and more well understood. The tension between the 6 days of creation in this translation by Schroeder and others becomes more and more excluded. So I'm not going to get into that. That's not something I'm particularly interested in discussing here, other than the fact that, again, I'm trying to say that the Torah is not a science book, and so I take issue, even with my fellow scientists who happen to be Jewish. I take great issue when that is trying to make this Torah into a science book, because then you could get into a situation where if the Torah says something, so there's there's an elementary particle called the crouton, and we never discover it, and somehow it's listed in the Torah as being evidence on which the Big Bang theory of the Torah rests, then the disproof of that would therefore bring up questions of the ultimate veracity of the Torah itself. So these are very fraught things to do. I personally don't like it. You're free to go and explore it and read it, be my guest, but I personally don't think it's a fruitful way to proceed. But let's get back to this description. Can we reconcile these two things? My claim is that is a very, very tenuous process indeed, and I don't think it's a necessary process. I don't think it's necessary to shoehorn in the 13.8 billion years, and notice that change is pretty radical. It's 2 billion years difference from the Schroeder calculations. That's a 25% error in your logic as a scientist, or accuracy as a scientist. So I see there's something in the chat. I cannot read the chat unless I stop the presentation, which I don't want to do. But if something's super urgent, maybe Andy, you could let me know. If I'm like, you guys have not heard anything I've said for the last 20 minutes, let me know. Andy, or
you're still all good. Everything's good. You can continue.
Okay, great. So we can't prove things. We can falsify things. Can we falsify what the Torah says? So that's a scientific question. It's not a theistic question or theological question. So the Torah says there was a beginning. Science says there may have been a beginning. This is from someone else's slide, Ephraim Palovnov. I don't know how to pronounce his name. But again, these are trying to make a correspondence between biblical description and Hebrew words, and then trying to convert those into modern scientific language. And at any point in history, this could have been done, and there would have been zero evidence for a singular beginning. In Isaac Newton's time and early part of Einstein's career, there would have been no evidence for it. So the Torah, in some sense, is going out on a limb by saying that there was a singular event. So we can ask the question, can you prove that there are multiple events? Can you disprove that there are multiple creation type events? If you could somehow prove that there were multiple creation events, that would call into question some aspects of the Torah's veracity and as a scientific book, not as a book of wisdom, which I claim is its primary contribution. I think anybody who goes and studies science and uses the Torah as their reference material is going to experience a great deal of challenges. So you see here in both of these, it says that science believes there was a period of rapid inflation. And then it says the Torah says there was rapid inflation. I'd never seen the word inflation before. Inflation has a very, very specific meaning. That means acceleration faster than light in the early universe. There's no mention of that, to my knowledge, by even claim by someone like Gerald Schroeder, who I disagree with in many cases. Nevertheless, it behooves us to ask the question, was there a singular point, a singularity, an origin? And again, this is something that's also untrue on the left column. There's no consensus, there's no proof that science says there was a singularity. A singularity is not just an event that occurred once. It has a very specific meaning in that you have infinite density, curvature, temperature of space and time at a finite point in time. And we have no proof of that, no evidence of that. And yet we can observe the after effects. If it did occur, we can ask, is the evidence that we see consistent with a singular origin or a very high temperature origin? So now we're going to do a little travelogue, not going back billions of years, just going back about 50 years. My wanderings through the desert of this world and the places that I've been. So I grew up on Long Island. I was a Jew. So at that point, I was a Jew. It's going to be a little complicated because you're going to see I go through more cycles than a cyclic universe. I started off, parents both Jewish, born to biological Jewish parents. Grew up on Long Island for the first 7 years. Parents got divorced. I used to love looking at the moon. And I moved in and lived with my stepfather, who was a devout Irish Catholic with 9 brothers and sisters, and was actually converted to Catholicism. I had a communion. I had a confirmation. I had my baptism, all at age 12 to 13. When I would have been preparing for my bar mitzvah. As a typical Jewish boy, had my parents not gotten divorced and had I remained in the faith. And it's funny because one of my kids, my oldest son, he's a couple of years away from his bar mitzvah, and he will say things to me like, I say, you have to fast on Yom Kippur soon. And he's like, but it's not my bar mitzvah, and I'm not obligated to fast until my bar mitzvah in a couple of years. And then I said, well, I haven't had my bar mitzvah either, so maybe I don't have to fast on Yom Kippur. So I never had a bar mitzvah. Don't weep any tears for me. I've received tremendous blessings, even despite that lack in my life. And my goal is to actually have my bar mitzvah someday, perhaps even in Israel on my 4th bar mitzvah anniversary when I'm 52. So stay tuned for news about that on my mailing list. So I was an altar boy, so I wanted to do everything you could possibly do. I'm a very kind of purist. I always want to do things the most authentic way possible. So I wanted to be a priest, and again, I was 12 at this time, and the closest thing you could do as a 12-year-old was become an altar boy. And so at that church called the Church of St. John and St. Mary, with the man on the left with the bishop hat was actually Monsignor Father Skelly, Robert Skelly, and he was a wonderful man. And he, was a great religious thinker, a great, a humorous soul, incredible gift for being with people. And I just had a delightful time. This is in Chappaqua, New York. And I wanted to be a priest for maybe a year or two. And so I kept it up the altar boy. And then I got a telescope on my 13th birthday. And between the age of 12 and 13, I met my first rabbi, which I call my rabbi, and that's Galileo Galilei, who was really the first person that I felt could communicate with me from beyond the grave, that he had been departed for so long, and yet his writing, his thinking, his artistry, he was a wonderful artist, poet, musician, all these things wrapped into one, and it just made me want to be him. And so when I got my first telescope, I tried to repeat the observations that he had made, which in some part contributed in a very strange way. I've realized that that the telescope has kind of been an integral part of not only the revelation of beautiful works and objects and things in the universe, but also of maybe the decline of religion. And the way it came about, I kind of have this cartoon from a tweet I put out once about what happened in the history of science is that Galileo didn't invent the telescope, but he perfected it. He made it into the device that he could use to do actual science. And the telescope came from the fact that people had just in the late 1400s, early 1500s, been able to use reading glasses. So having pieces of glass that they could combine together in front of their eyes, and that would improve their vision. And how do they know they needed glasses? They would look at standard print, font of a certain size, printed in movable typeset printing that was only invented by the Gutenberg Bible by Gutenberg himself in the 1400s. So the fact that the first thing ever printed then became the eyeglass or eyesight standard is kind of ironic, because then later the telescope came to overthrow the church belief that the earth was the center of the universe. And that led to all sorts of things like secularism and humanism and ultimately the decline of religion itself. So it's kind of ironic that the Bible was kind of responsible for its own decline. But that's not really the subject of this discussion. It's more Galileo and what he saw through this telescope and what he wrote in his book, De Sidereis Nuncius, and later in the dialogue, which I've just published as an audiobook with about 6 of my physicist friends, the first ever audiobook by Galileo Galilei. So I have 2 written books and 1 audio-only book. And what Galileo did is he went on a book tour and he tried to sell copies. You see in his right hand, he's holding pictures of sketches and stuff, and he's showing it to these senators in Venice, and they want to buy the telescope and so forth. And he became incredibly famous, like this person here. He had 100 million Twitter followers. Now he had the equivalent of it. He never left Italy, and people as far away as Asia knew about him in his own lifetime. It's really quite incredible. And of course, what he did is usher in this notion that the universe is not centered on the earth, it's centered on the sun. And that got him into great trouble with the Inquisition, because the Inquisition forbade the teaching of Copernicanism, of heliocentrism, in saying, in my opinion, in a wrong interpretation of the Hebrew, apparently, allegedly from the book of Joshua, that Joshua caused the sun to stand still, or Hashem, God, caused that to stop rotating around the earth. And for that, apparently, that was one of the main sources of the sun being in orbit around the earth, as shown on the left. And of course, we know that's wrong today. And in between, when Galileo was about to be persecuted, he thought he could get away with it, because in his book, The Dialogue, as my friends and I read it as a dramatic work of literature, he says in it, basically, it's like a proof of God's existence, that God can make whatever he wants. And so he said here, I do not feel obligated to believe that the same God who has endowed us with sense, reason, and intellect has intended us to forego their use. And he also said, the Bible teaches us how to go to heaven, not how the heavens go. So he tested the waters back then. And don't forget, only 11 years before he wrote his book, Giordano Bruno was burned at the stake. So Galileo got off kind of easily. He was house imprisoned, courtesy of the Inquisition, the Holy Office, as it was called. There he is, about to get hit with this conquistador's sword. But he was sentenced to prison. His prison is this villa outside of Florence, where I was pleased to host a conference in his honor about 7 years ago. It still has olive trees and grapevines. It's a pretty nice prison. I think Bernie Madoff would have been happy there. But nevertheless, he was imprisoned and threatened with possible torture. He was actually never tortured, but there were threats about it. So after that period of time, after learning that Galileo had never been pardoned for the sin of suspicion of heresy, that the Earth was no longer the center of the universe, I became disenchanted with religion. I thought any religion that would persecute my hero wasn't worthy of me being a part of. So I actually left the Catholic Church and completely lost my religion and was an atheist for many, many years, from the time of early high school till graduate school and beyond. And I kind of used this deduction, which was that, Galileo was never pardoned. He was never forgiven for what he did, even up until the time of the discovery of the cosmic microwave background. He's actually never formally been pardoned. He was ruled correct by Pope John Paul, the great Pope John Paul, in the 1980s. But that was long after I was kind of disenchanted with the Catholic Church. So I kind of abandoned my faith, and I said, to myself, Judaism, was around before Christianity, and if I have problems with Christianity and it came along after Judaism, Christianity must have fixed all the flaws in Judaism and updated those. And there's a lot of similarities between Judaism and Christianity, but there's a lot that Christianity overthrew in Judaism. So it's very different. And so that logical syllogism, as it's called, deductive argument, is not really a kosher form of inference. And yet, that's kind of the way my mind was working back then. And eventually, after graduation from Brown, I went to Stanford as what's called a postdoc, and I had ideas to test whether or not the Big Bang actually occurred. Ideas for a telescope. There was just one problem. I wasn't being paid to do that. I was being paid to work on a completely different project. And so my advisor, by the way, if anyone knows this German, they know that the motto of Stanford is Die Luft der Freiheit weht, which means the wind of freedom blows. And I was blown free of a paycheck very shortly after being at Stanford. And I was actually fired by a professor whose name is Church. So I got in trouble with the church too, very different than Galileo, of course. But it did involve a refracting telescope, just like what Galileo built. And I'm not comparing myself to Galileo or to the fate of suffering at the hands of the church. From there, I went to Caltech, which is a small technical college in Los Angeles. And about a year after I got there, 9/11 occurred. And again, at this point, I had really not, I had not been Jewish for, practicing, observant, doing anything for 20, 30 years. And yet, when 9/11 occurred, it became increasingly clear to me that there was something about Judaism that I didn't know. It was kind of gnawing at me that I knew so much about Islam, and it was kind of perhaps unfairly being tarnished in some ways in the media. But everybody knew about Islam and what did it stand for and what is it a religion about. I knew a lot about Christianity and Catholicism because of my peripatetic upbringing, but I knew nothing about the religion I was born into. So that was kind of when I resolved to start learning about Judaism. And I actually started teaching myself to read Hebrew, and I studied with a rabbi, and I went to Israel, and I studied in a yeshiva for a month, and I vowed to try to establish descendants, to have children, to have a Jewish family, and to bring up kids according to the religion of my birth that had increasingly appealed to me. And I saw it as sort of not in an ethnic sense, but actually in almost a moral philosophical sense, that I had been given a history, a legacy that was very precious, and I wanted to know more about it. And if it was valuable to me, I felt that I could use its wisdom of generations, of millennia, after all, to better my life and to break out of the cycle of divorce, despondency, depression, anger, etc., that had driven my family apart. Of course, nothing is a cure-all for those things, but nevertheless, it offered some hope. And in that sense, especially the ability of the Torah to speak to the dynamics of families. Don't forget, Abraham, doesn't get pregnant. Sarah doesn't get pregnant until she's 90 or so. They have children that fight with each other. Of course, Jacob and Esau fight and want to kill each other. Joseph and his brother. So the Torah is very true to what life is like. I mean, nobody has a hopefully, families where your brother's trying to kill you, Cain and Abel. But nevertheless, it speaks in very realistic terms about the limitations of the human condition, and that appealed to me. It wasn't aspirational that I couldn't ever achieve. It wasn't far from me. It was something I could become, and I felt a great appeal to it. And so I started out a mission to see if there were these blessings. And I actually got blessed to come to UCSD in 2004, where I've been ever since. 18 years I've been here on the seashore there that Abraham was promised to have sand-like numbers of offspring. So I don't know about that. My wife's not down for that, but nevertheless, it was something that I knew I had to continue this mission to try to understand if I could reconcile some of the aspects of science with the Torah. And so we built this telescope. It was called BICEP. We took it from San Diego and Caltech. We took it down to the South Pole, Antarctica. So now I'm traveling with you to Antarctica. We shipped it there. It's a refracting telescope at the bottom of the world. I've been there twice. And it's an otherworldly ice planet, like in Star Wars, the planet Hoth. And it's been a challenge to get to for 100 years more. It was only discovered in the early 1900s, the South Pole. And the people on the bottom all died trying to get back from the South Pole and lost their battle, froze to death in March of 1912, 110 years ago this year. And they did it for kind of the same nationalistic pride that we went to the moon or people do stuff as nations. And they were also interested in science. And I thought it's an amazing place to be. It's still very dangerous. If you go there now, you're as likely perhaps to lose your life. Not to the cold conditions because you wear very warm, comfortable clothing, but to the fauna that are so violent and so destructive. So those are brothers. The one on the right is his name is Cain. But maybe they're just mad at other penguins. Maybe they get along with people. So I try to get close to one. The second time I went down there, it was also extremely dangerous. Maybe not quite as dangerous as when Scott and company froze to death. But we actually made this discovery that we were trying to make. In other words, we saw the imprint that would have proven as close as you could, beyond a reasonable doubt, that the universe began with a Big Bang. And that was called a detection of this inflationary signal. And you see at Stanford, back where I used to be, there was a video put out. It got 3 million views in a day or two. There was a press conference at Harvard. And I described this in my first book, Losing the Nobel Prize. And I kind of send links to folks on my YouTube channel that show this. We were on CNN. We were in the most important newspaper in all of the planet, the San Diego Union Tribune. You see that on the left, and also in this paper called the New York Times. And I wanted to really draw your attention to what it shows in the middle of that column of the New York Times. It says, "Space ripples seen as the Big Bang smoking gun." So we had done it. This is on March 17th, 2014. On the left, you see this very, very wrinkle. We detect evidence of such an event after the Big Bang. I was a little bit more cautious in that article. And you see something in the top. You see, history keeps rhyming. It doesn't repeat. There's Putin invading Crimea. Okay, so 8 years later, he's invading Ukraine, right? And the bottom, you see The Economist. It sounds like some guy just saw the beginning of the universe. That's kind of cool. And then we were whispered about winning a Nobel Prize. Now, spoiler alert, my first book's called Losing the Nobel Prize, so at least you know I didn't win it. But perhaps other people could win it. And the question is, why? Why didn't I win the Nobel Prize? Why didn't anybody win the Nobel Prize? So you made it when you are printed up in The Onion. And you can see this about this quote from below. So these are talking about the meaning of forever. They're talking about the Bicep 2 experiment. This is a month after the announcement was made. So that was kind of ticklish to see that. But everything had to be kind of evaluated and taken with a grain of dust, as it turns out. So there are this cartoon shows these two housekeepers, whatever, in a hotel maybe, looking out and saying, "It's so beautiful, but I can't stop thinking about all that interstellar dust out there." Now, why would they be thinking about such things? Well, it turns out the universe is a pretty filthy place. It's full of failed comets, failed asteroids, meteorites, galactic schmutz, as we professionals call it. And this dust can actually mimic the imprimatur of the Big Bang signal that we were seeking. And in fact, it did. And it replicated and fooled us into believing that the signal that we saw was actually the harbinger of the early universe's birth pangs, but it wasn't. It was actually the mere presence of microscopic grains of dust permeating our galaxy, not even the cosmos, just our galaxy. And it tricked us into believing that we had detected once and for all the Big Bang smoking gun. So now we know the universe isn't so pristine. We can't just look here from Earth all the way back to the beginning of time. That instead, it's kind of smoggy, it's kind of smoky, kind of reminds me of Los Angeles on a bad day. The universe has tons and tons and tons of this type of substance, the very humble substance, but one that we didn't account for in its completeness, and that's called dust. And so we have to pivot. We have to pick ourselves up and dust ourselves off. Even when our Nobel aspirations are blown away into the dust of the wind, we still have to do more. And so we have created a new experiment, and it's called the Simons Observatory. And this observatory has a goal to not only detect these aftershocks of the Big Bang, if the Big Bang occurred, but also to detect the presence of dust in the universe and get rid of it and account for it accurately and precisely using an array of instruments that I won't talk about in great detail. But here's a couple of beautiful pictures of our site, and I'll show you some data or some video from our site that we just got today. So you can follow us online. It's at 17,200 feet above sea level in the Atacama Desert of northern Chile, which is considered the driest desert on Earth. It's called the Desert of Deserts. I actually thought it was the Desert of Deserts. When I went there the first time, I was sorely mistaken. But it's on this plateau high above sea level, where you can basically look straight up and feel like you're looking into the inky blackness of outer space. From there, we're attempting to build, courtesy of very, very generous funding from both the Simons Foundation and the Heising Simons Foundation and our member and partner institutions that have been so generous, including UC San Diego, Princeton, Penn, and Berkeley that founded the observatory in 2016. We aim to be taking data with it in 2024, which is just about 2 years from now. Less than 2 years, we aim to have data from both the universe's inflationary origin, if that indeed took place, and from dust, and potentially rule out or constrain these other models of cosmic genesis, cyclic universes, bouncing universes, static universes. We can rule all those out. Perhaps there would be enough credulity in the existence of inflation and therefore the single Big Bang. So again, coming back to one of the 3 quotes I started with, God said to Abram, I will make your offspring like the dust of the earth, so that if one can count the dust of the earth, then your offspring could be counted. So again, we heard about stars will be like the children, the offspring. Now we hear dust. So can we count the dust? Well, to count dust in cosmology, we need to have very smart people working with us. And these are some of our students just here at UC San Diego working with us. They are right next to the Price Center, it's our student center here. They're some of the most brilliant people that I would work with for free, and I can't believe that I get paid to work with these geniuses. We're building refracting telescopes, not unlike one that Galileo himself would recognize, to look back and to get the earliest evidence, not only for the existence of gravitational waves and the Big Bang, but perhaps for also, at the same time, ruling out competing models for how the universe could have been formed but didn't. To do that, we have to measure dust and measure the CMB. So we have 3 different telescopes. And that way we can count dust as well as count the signals that we're looking for. And we have these 3 telescopes here, one of which is in my laboratory, being completely built by my colleague, Professor Cam Arnold, and our students and postdocs here. And another one at Princeton University, led by Lyman Page, and we have one of my colleagues on the phone, Fred Carl, who's an invaluable member of the team. And we also have a 3rd telescope, which is being built by my colleague Adrian Lee and his group at UC Berkeley. These 3 telescopes will sit on this very strange-looking platform, which has this thing called a co-moving shield. I only point that out because we just recently took delivery, and here's a time lapse of just about a day. You're going to see underneath that giant arrow, you're going to see a lot of construction activity. This, remind you, is at 17,000 feet above sea level. The atmospheric air pressure is half that which we feel here at sea level. We have to be continuously on oxygen. There's tremendous danger from ultraviolet rays. The incredibly dry, obviously, you almost see no clouds at any time. The sky is completely black when you look overhead. And it's a tremendously alien environment. And oh, by the way, those little pointy mountains are volcanoes that we think are dormant, but not extinct. And every so often they erupt. So you see those big boxes underneath that crane. So we have to provide everything. Cam and others have built out the site with infrastructure, with concrete, with diesel-powered generators, with laboratories in the foreground, getting cranes up to 17,000 feet. It's an incredible challenge, but we have an incredible team. And I'm so pleased to be a part of it, all in an effort to measure simultaneously the cosmic signals that we care about, as well as measuring the dust signals. So I want to conclude by saying this famous quote, which we led off with. The Lord took Abram outside and said, look up and count the stars. He was commanding him to do it. He says, if you can. That's how many descendants you will have. Now, it says that they will be previously, it said they will be you'll have as many offspring also as the dust and of the sand on the seashore. So I'm an astronomer, and I wanted to do a calculation. Are there more grains of sand in the Earth's beaches, or are there more stars in the universe, or are they the same number? So it turns out you can go through the calculation. In the Milky Way galaxy, we know there's about 100 billion to at most 500 billion stars. We can count them up, and we can do a simple estimation of how many grains of sand there are, and it comes out to be about 3 billion grains of sand. So there's more than 1 billion times more, about 1 billion times more, 33 million or so times more grains of sand on the seashore than there are stars in the sky. And yet, what did Abraham do? He went out and he tried to do it. So this is a tour of our galaxy. Now imagine trying to count every single star in this galaxy. Obviously, that's impossible. This is kind of a simulation of what it would look like. We can't get far enough away to actually do this type of a journey through the galaxy. But every single point of light is a star, and then there's a lot of dust in there too, of course. So each star is unique. And as it said, when we try to do the impossible, amazing things often happen. It is through persistence that we discover our true abilities. So we can't count the number of stars in the sky. We couldn't count the number of grains of sand on all the beaches of the earth, but that shouldn't stop us from trying to go into the impossible. So, what are the takeaways? Again, Torah means wisdom, science means knowledge. They're not the same thing. Can we prove God exists? No, that's not what scientists do. We disprove things that don't exist. And the last lesson is to take away the fact that Abraham tried to do the impossible. He knew it was impossible, but when you have something like an entity like God telling you to do something, you don't say no. And I think it's a valuable lesson that we can all take away. And it's not a coincidence that my podcast is also called Into the Impossible, which you can find when you do your homework and visit both my email list to get updates from around the universe. That is cosmology, astronomy, theology, religion, all sorts of events. When I start speaking around the country again, you'll be able to get in touch with me. I might come to a city near you. And lastly, where I keep my podcast, Into the Impossible, where Abraham would surely go, it is accessible on YouTube and anywhere you get your audio podcast as well. And with that, I want to thank everybody and hope that you will all stay in touch. And I'm happy to take some questions, Andy.
All right. Yeah, thank you so much, Dr. Keating. That was unbelievable. Thank you for sharing your story and everything that you did with us tonight. As I said in the chat, right after he ended, the floor is open to any questions anyone may have on anything that you're interested about learning more about Dr. Keating. So yeah, I'll just give it maybe a minute here, but actually I didn't get any questions in the Q&A and none in the chat yet, so I'll give people some time. I'll kick it off with a question I had. During your academic journey, have you experienced any difficulties, in developing these refraction telescopes, and what did you learn from those challenges that you've come across?
Did I ever experience any challenges? Yeah. So we've experienced basically nonstop challenges in any of these projects, whether it was getting the funding to do it, getting someone to believe in you. I had a mentor, Andrew Lang at Caltech, who believed in me in a way that no scientist had ever believed in me, that you could actually measure the early parts of the universe's evolution. And Andrew was a towering figure in my life, about 10 years older than me, kind of like an uncle. He would give me all sorts of advice. And in January of 2010, when we should have been celebrating the greatest heights imaginable, if we had just deployed this telescope to the South Pole, which was my vision and his vision, he took his own life, and nobody knows why. And I write about him as kind of this just monumental loss for not just me and cosmology, but obviously for his children, his family. And it's something I could never really wrap my mind around. Not that I was the most important consideration in his life, but just being so close to somebody who believed in you, really the first true person I felt that way about, and to lose him. So that was devastating to me. And then losing out on certain opportunities to measure and to be a part of different things. But you get, like, if I point out in my book, if I hadn't been fired from Stanford, which I thought was the most challenging thing that ever happened to me, the worst thing that ever happened to me, one of the greatest institutions of higher learning in the planet, and I get fired, the only time I've ever been fired. And yet, if that hadn't happened, I wouldn't have eventually moved to San Diego, where I met my wife and had children, and been able to do everything else I've been able to do in life. Since then, so a lot of times you think something's really bad, but only through the clarity of looking back through the power of the telescope, the power of perspective. That's what the telescope means. And according to Galileo, it was called a perspective tube. I got that perspective, but only through distance do you know that what you thought was a challenge, it was actually a great gift.
Yeah, thank you for answering. Yeah, so we actually did get a few questions coming in. The first one I saw was from Rena, and the question is, what are your next steps to prove the Big Bang?
Oh, yeah, that's my friend Rena. So Rena is also a great podcaster, and she's married to a great scientist named Zev. So shout out to them. So the Simons Observatory will take us to measure not only the signals that get in the way, the contamination, the systematic errors that contaminate our measurement, but we'll also measure with deeper precision and greater accuracy the potential existence of these waves of gravity, which would then be evidence for inflation, which would then be evidence for the Big Bang starting off in a quantum fluctuation singularity, and also tie into something that I didn't have time to speak about called the multiverse. That would be maybe we'll talk about that at a different event, perhaps.
Amazing. And then the next question we had coming in is, what is the best advice that you have for students who struggle with their identities of being in STEM and Jewish?
Ah, well, um, I think that the most important thing to work on in as a STEM aspiring STEM professional, I've never seen it get in the way. In fact, in STEM is much less likely to face some of the challenges that you face in if you take Judaic studies or international relations. So I'm not sure why this question would be really pertinent to STEM in that STEM is traditionally science, technology, engineering, and math. It's really focused on practical matters that don't involve necessarily a confrontation of your Jewish ethnic identity, cultural identity, or even religious identity. So I've never found those in conflict at all. I would be much less, optimistic if I were studying, something in the humanities where it's often, there are a lot of challenges to that come from things like the BDS movement. We don't have that. There have been some attempts to do that in the hard sciences. Luckily, they've been refuted in most ways.
Yeah, yeah, I can definitely speak to that as a student as well. What you're saying. Um, yeah, and the next question we got is from Luba, which is actually my mom. Can you provide an example of two of your disagreements with Dr. Schroeder?
Okay, so hi mom, happy Mother's Day. Uh, thank you for making Andy. So disagreements with Schroeder. So again, there's two different philosophies. One is to say the Torah and science are what Stephen Jay Gould, the late great atheist but Jewish historian of science at Harvard, said were non-overlapping magisteria. In other words, they are domains that are self contained and are completely intact and wholly disparate from one another. That religion and science have nothing to do with each other. That is in direct opposition to Schroeder and others who attempt to reconcile a one-to-one correspondence between statements in Genesis and statements in science. I do not believe for myself that is the purpose, and I think Gould agreed with this. That you cannot do specifically that. You cannot say that one has a purpose and without opening up the possibility that then okay, so you're going to use the Torah, you're going to use science to prove things in the Torah. Well, then what prevents you from trying to say that the Torah is going to teach you things about science? That to me is very perilous because there are tons of things that aren't addressed in the Torah at all. dinosaurs, evolution, and more or less the perspective. And this is not just me. I've had rabbis and other people who are scientifically erudite, including the former chairman of the Caltech math department, Barry Simon, who's a Torah, very Torah true Jew, as anyone who knows him knows. And there is a great difficulty with some of the scientific proofs, quote unquote. So let me give you an example. So he doesn't say this. He's much too brilliant to say this, but Schroeder said something like, the universe will never accelerate. It will never get the universe expanding, but the expansion will never increase with time. He actually doesn't even mention it in his book from 1996. Why? Because we didn't know that the universe is accelerating or expanding. That completely changes the dynamics, not only of our future, but of how the first few days behaved. And so we can't trust to the precision that he's trying to wedge together. We cannot trust that scientifically to be accurate. When he wrote his book, we didn't know anything about this mysterious force which dominates the amount of energy and matter and energy in our universe, causing it to accelerate. And so all the more so can we not use the Torah itself. I mean, you have to say, even you might love Schroeder, I know many of you do, but you can't say that he's superior to Moses. I don't care how much you love him. And so Moses is silent on this, right? And there are many statements that are troubling if you think of the Torah as a science book. And so I say, again, Torah means wisdom. It means what you teach to your children, this Torah. I don't teach my children A Brief History of Time by Stephen Hawking. Actually, Hawking had a lot of problems as a parent, as a husband. I don't want to get into it. But I don't use him to teach my kids wisdom. I use him to teach them knowledge. Knowledge, by definition, is meant to be eventually refuted. Torah is meant never to be refuted. So if you try to wedge something in too closely, it could be like saying the earth is spherical, when in reality, better that we know science, we'll know that that's not true. I'm not saying don't read it. I'm not saying I don't respect the person. I'm just saying there is a great deal of controversy among scientists about it, his way of interpreting it.
Got it. Yeah. Yeah, great response. I think just to be respectful of your time and everyone's time that's on, I think we'll wrap it up. You wanted me to do this one last question that we had? You have time?
Yeah.
Okay, yeah. So we'll wrap it up with this last question here from Chad. And it is, can the formation of mass be seen as a result of inflation or expansion?
Oh. No. So mass doesn't have to do with inflation. In mass, we think about as the formation or conservation of energy in cosmology. There is no conservation of mass in physics or in cosmology. You can create mass from pure energy, and some say that the universe itself was created from pure energy. And that has a context in religion, but it also has a context in what's called quantum field theory, that you can play certain roles in quantum mechanics that then can allow you to borrow energy on very brief timescales, such as those that prevailed at the beginning of the universe. And that can actually be used, in a sense, to instantiate matter, which has mass. So no, we can't. The fields are allied and concomitant that if you did have inflation, it would explain what powered and propelled the Big Bang to expand. But no, you can't get directly there's no current. That doesn't mean there never will be, but there's no current mechanism from pure inflation to get pure mass. That's a very sophisticated question, though.
Amazing. All right. And with that, I think we will wrap up today's talk. Again, thank you so much for speaking, Dr. Keating, and for all the support from all of the other Jewish leaders in our community, Rabbi Ertel, Lisa, and Karen. Thank you so much for being here today. And thank you to everyone that stayed on through the entire talk. It was great having you. Hope you all learned something new today, as I strive to do every day myself. And yeah, with that, have a good night.
Thank you, Andy. Thank you, Dr. Keating.
Thank you.
Thank you,
Dr.
Lisa.
Keating.
Thank you, Karen.
Happy Jewish American Heritage Month, everyone.
Yeah, and that too.
Thank you, guys. Bye-bye.
Thank you
Great
so
evening.
much. Bye.